The two periodic trends I want you to focus on are atomic radius and the ionization energy. Atomic radius, or the atomic size, is the volume of the electrons in the clouds in the atom. Okay. Some fancy words there. Essentially, how big is the atom? Which the size of the atom is dictated how far the electrons go out. So essentially, how far out are the electrons? The higher the quantum number, the further the electrons are out. Okay, the smaller the quantum number, the further the electrons, or the closer to the nucleus those electrons are. So we're going to have two different trends to watch out for. We have our basic periodic table. Okay, yes, this very, very crude shape of a periodic table. But what happens is, as we go down the periodic table, atomic radius is going to increase. And that's because as we move down the periodic table, the quantum number increases. The quantum number says, higher the quantum number, the further away from the nucleus the electrons are. So I'll just write that in summary. So as we move down the periodic table, our atomic radius is going to increase. And that's because our electrons are in a higher quantum number or a higher quantum level, so they're further away from the nucleus. So this is the main trend for atomic radius. There is a minor trend that occurs. So a smaller scale change, and that's from moving from the left to the right on the periodic table. And as we move from the left to the right, the atomic radius is going to decrease. So when we move from left to right, atomic radius decreases, and it's a much smaller change than what's happening in here. Okay, so this is a minor difference. So our atomic radius is going to decrease as we move from left to right. Okay, our quantum number stays the same because we're moving left to right, so we're in the same period. So the quantum number stays the same, but those electrons are experiencing a greater positive charge because as we move from left to right, we're increasing the number of protons in the nucleus. So more protons means more positive charge, more pull on the electrons, and therefore a smaller atomic radius. So as we move from left to right, we have more protons, a higher positive charge, pulling the electrons in closer, so our atomic radius decreases. All right, so as we're moving from left to right, and we're in the same quantum level, so quantum level doesn't have an effect on the size moving from left to right. So it's a very minor difference, but it does get smaller as we move to the right of the periodic table. And the reason for that is because we have more positive charge, more protons, pulling the electrons closer to the nucleus. And more protons means a higher charge, so a greater pull on those electrons, pulling them just slightly closer to the nucleus, making the atomic radius smaller. Understanding these are very important because that's going to relate to our ionization energy. So the ionization energy is the energy needed to remove the least tightly bound electron from an atom in the gaseous phase. Okay, again, some fancy words. So it's the energy needed to remove the least tightly bound electron, so the furthest away, the electron that's furthest away from the nucleus, and we're going to remove that from an atom in the gaseous state. This is just this gaseous state portion is a technicality. It's there for the definition. Don't worry about it. Okay. So we're looking at the energy needed to rip off an electron. Essentially, the further away from the nucleus the electron is, the easier it is to pull off. Okay. The further away from the nucleus, the less it feels that positive charge. Okay. So what happens is we're trying to remove the outermost electron. The closer to the nucleus it is, the greater the pull, the harder to remove. The greater the ionization energy. So if the electron is close to the nucleus, okay, it's closer to that positive charge, so it's a greater pull on that electron. Greater pull on the electron means it's harder to remove. If it's harder to remove, that corresponds to a greater ionization value. So atomic radius has to do with how close the electron is to that nucleus. Okay. So we're going to look at the same two trends. We want to look at going down the periodic table and going across the periodic table. Again, going down the periodic table is the greater trend. Okay, as we go down the periodic table, the electrons get further away from the nucleus. Further away from the nucleus, easier to remove, the lower the ionization energy. So as we move down the periodic table, our electrons are moving further from the nucleus, so it's easier to remove because they have less pull from the protons, so our ionization decreases. Moving left to right on the periodic table, our electrons are getting closer to the nucleus because there's more positive charge. They're moving closer to the nucleus, they're feeling a greater pull, so they're harder to remove. So our ionization energy is going to increase. So our ionization energy as we move from left to right is going to increase because there are more protons pulling the electrons in tighter. If we're holding them in tighter, it's going to be more difficult to remove those electrons, so that ionization increases. And just like for our atomic radius going from left to right is a minor difference, so is our ionization energy. The movement going down the periodic table is a much greater effect than moving from left to right. So there are some Q&P in your book and some questions on sapling that compare, looking at two elements, which one's going to have the highest ionization energy, which one's going to have the greatest atomic radius. So definitely want to work on picking which one is larger. Also, you want to be able to come up with the explanations. Okay, and I'm not needing you to be super creative or try and figure out different ways of saying the same thing. These are the explanations you want to be focusing on. Okay, when I ask an exam question, I'm going to ask you, say, which element has a higher atomic radius, phosphorus or sulfur? Why? Okay, and I'm specifically going to ask you, use terminology discussed in this section. Okay. So what I'm looking for there is I don't want you to just say phosphorus has the larger atomic radius because it's further to the left on the periodic table. So what? That doesn't tell me anything that you've learned from this section. I'm looking for an answer like phosphorus has a larger atomic radius because it's to the left of sulfur on the periodic table. It has less protons, so it can't pull the electrons in as close, meaning it has the larger radius. Okay, I'm looking for those keywords. Can you say, are there more or less protons pulling in our electrons, or not pulling them in as tight? Can you understand and apply this concept of the quantum level for how far away are the electrons? Okay. So on that exam question, yes, understanding and being able to dictate the trends of whether or not it's going down the periodic table or across is important, but I'm also wanting to see if you can get this specific vocabulary so that you can explain what's going on in a scientifically sound way. Okay, so essentially, rather than just answering because, I would want an explanation of that. So worth practicing, definitely sapling Q&P for your exam.